Hi, welcome back to RamZland. Today I want to show you quantum locking with type 2 superconductors. Check this out. For this investigation, I'm using liquid nitrogen that is negative 320 degrees Fahrenheit. It's really cold. I'm using a special N52 neodymium magnetic track. I'm using type 2 YBCO superconductors, a large one and a small one. These are yttrium barium copper oxide conductors. I'm using a wide mouth borosilicate door to cool those in, a tray, some plastic tongs. This is a special track that was made by Dr. Boris Almog in the University of Tel Aviv. The first step is to cool your superconductors in liquid nitrogen. So I just put a little bit in this tray and a little bit in this wide mouth door, and you can see that type 2 superconductor is cooling down there. One important distinction in this experiment is to note that these superconductors are non-ferromagnetic. So when I hold this really strong magnet over the superconductor, it doesn't respond until it gets to a certain temperature. And when it reaches that temperature, I can lock it in place. Okay, once your superconductors have cooled, you can observe quantum locking. And one thing you'll notice is that it literally levitates over the magnetic track. And it will continue until it warms up. And you can put another superconductor over it, and they won't be attracted to one another. Here you can see one superconductor passing right under the other superconductor. In this demonstration, you can clearly see that the superconductors are not attracted to one another, as one can pass directly beneath the other. They are literally locked in place. Just amazing. Look at that. So if you're like me, you might be wondering, how is this possible? How can you lock the superconductor in place and have it rotate without it falling? Let's find out. So why do these superconductors levitate over the track? It's because of the Meissner effect and flux spinning. If you look at that first circle in the diagram, it has magnetic lines going around the superconductor, and the second one has magnetic lines actually going through the superconductor. The one that has the magnetic fields going around it explains the Meissner effect. So when a superconductor reaches its critical temperature, in this case negative 320 degrees Fahrenheit in liquid nitrogen, it expels the magnetic field around it. But that doesn't explain why the superconductor doesn't just fall off the side of the neodymium track. Type 2 superconductors, however, have an imperfect lattice. So the yttrium barium copper oxide crystal lattice has little openings in it called flux tubules, where you can have a magnetic vortice swirl right through the superconductor, thereby locking it in place. This phenomenon is called flux spinning, and that's why the superconductor can stay over the track and go around in circles without just flopping over on the side, or why one can float over another and the other smaller superconductor can be locked in place at a lower altitude over the magnetic track. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.